This is Brian Olson, manager of the Monsanto Water Utilization Learning Center in Gothenburg, Nebraska, and today I'm going to talk to you about a basic irrigation principle called evapotranspiration, or ET. So what is evapotranspiration? Evapotranspiration is made up of two parts: evaporation and transpiration. So evaporation is when we have water that leaves the surface as a vapor and is not moving through the plant. So we actually want to reduce evaporation out there in our crop production fields, and we want to see more transpiration when we want to have that water move up through the plant and cool the plant and then move through the stomata and enter the atmosphere as a vapor. So we want to, again, increase transpiration, which cools the plant, and we want to decrease evaporation, which is unfortunately the loss of moisture from the soil surface or from other surfaces out there in the field, and it's really not doing the crop any good when the water leaves the environment as evaporation. So let's take a closer look at evaporation. What are the big drivers for evaporation? So here we've got the soil surface, and we've got water that is close to the soil surface or at the soil surface. And again, we've got sun over here, a nice sunny day. So warm temperatures with a very bright sunny day, a lot of wind and low relative humidity is going to increase evaporation of the water off of the surface and causing it to turn into a vapor and leave the environment and enter the atmosphere. Okay, so what are some things that we can do to decrease this from occurring? Well, first thing that we can do is have stubble out there. So wheat stubble is very good at providing shade out there, but corn stalks can also be good at reducing evaporation along with the residue from those corn stalks. So this stubble out here shades the ground, decreases the sunlight from hitting that soil surface and transferring energy to that water droplet that would then cause it to turn into a vapor. And then it also decreases the temperature at the soil surface. So having that stubble out there shading the ground really provides a big benefit. It also decreases the amount of air that actually hits that soil surface. So we've got a buffer area here. Let's say we've got stubble out there that is about a foot tall. This provides a buffer where that wind is blowing over the ground but actually not reaching the soil surface because we've got this stubble layer there. So it's decreasing, not eliminating, but decreasing the amount of evaporation off that soil surface. The next thing is transpiration. So here we've got our corn plant, and it is transpiring water. And we've got a corn plant here, let's say at VT. And then we've got another corn plant here at V4. Okay? So the crop growth stage is a big driver of transpiration. The plant that is at V4 is using less water than the plant at VT. And this will be consistent if you expose the corn plant to the same environment, let's say a 90-degree day with the same amount of sunlight, the same amount of wind. That plant at V4 is using less water than the plant at VT. However, you can see some differences out there when you expose that plant to warmer temperatures at V4 than at VT. It's going to change that dynamic. But generally, if you're exposing them again to the same environment, the plant at V4 is using less water than the plant at VT, and that's going to be the crop water use. So if we look at the crop water use over time, we've got our scale here, and so we look at the 30-year average. We've got our crop water use. We've got the plant using the highest amount of water typically at VT to that early reproductive stage. Okay, and we're going to say that comes in at 0.4 inches of water per day. Inches of water per day. Okay, so the plant is typically using about 0.4 inches of water per day at that tassel time frame. And then as it goes through its growing season, it decreases as it gets to maturity. And again, it's not using as much water at the beginning of the growing season because that's when the corn plant is smaller. However, year-to-year variation can increase or decrease the amount of water being used on average. So here we say we've got the yellow line is representing what's happening in a particular year. So we've got the crop water use being tracked close to what's occurring on average. And then we enter into a time frame where we see higher than normal water amount being used by that plant because we have warmer temperatures with low relative humidity. And let's say it's a 95-degree day with a lot of sunlight and a lot of wind. And this occurs for a week. So we're actually seeing pretty high levels of water use being used by that plant. Then we go back to more normal temperatures, and the corn plant continues on about with average crop water use. And then as it gets close to tassel time, we see this big reduction in water use because the temperature goes down to 70 degrees for a week with low amount of wind and a lot of cloudy weather out there. And so we see a significant reduction compared to what we would normally expect for crop water use. And then that front moves through. We get more normal temperatures. Crop water use goes back up and follows the 30-year average, declines as the crop matures for that season. What does this variation potentially cause out there? Well, if we look at this early season, so we'll say the plant was around V10 at this time frame. There's a fairly good likelihood that if we were not looking at the actual ET for that particular year and just looking at the average ET or what we would expect, that we were under irrigating the corn plant at that time or shorting the corn plant with respect to water, and obviously decreasing the yield potential because the corn plant is entering into a stressful condition at that time. Here we are actually over irrigating if we were looking at the average crop water use by the plant. We're actually putting more water out there in the system than is needed. So we're spending more money than is needed on that plant because, again, we've got lower temperatures out there with a cloudy day and the corn plant is not using as much water. So again, this is an important concept for farmers to keep in mind as they look at irrigation scheduling. We have the average, which is the black line. And again, it's just an average, but it is driven by the crop growth stage. So again, smaller plants going to use less water than a plant at that VT to R3 time frame. And then Mother Nature as a whole drives the other components. So we've got temperature, relative humidity, sunlight, and wind, all factors that drive the crop water use for that particular plant in that given year. So if we stay on top of this, we can irrigate the corn plant properly and again, not short the corn plant early on in the growing season in this hypothetical situation where we've got warmer than normal temperatures. And then we're not over irrigating the corn plant either when we've got lower temperatures than normal. And the ET or evapotranspiration can be calculated for a particular area. Typically, your local university will be calculating ET for the irrigators in the area, and please pay attention to that because that takes into account this year-to-year variation driven by the crop growth stage, but driven by the weather for that particular year. So with that, thank you for taking a few minutes of your day, and we will be talking to you in the future about other irrigation topics.
For more information on this topic, you can download the Monsanto Irrigation Handbook for the Great Plains by using the following address.
This video was produced by the Monsanto Water Utilization Learning Center.